I think it's live. Sorry, everyone. Just give me just a moment. Alrighty. Hi everyone. I'm streaming to both Periscope and Twitch. I can't really watch both the comments at once, so if you want to interact with me, I recommend watching it on Twitch. But I will do my best to check in on the Periscope stream every now and again as well. Okay. Just getting all my stuff set back up. Alrighty, so I'm going to try to put together this Eurorack Synth Noodle Toaster this time. I'm going to have to do this in multiple phases because it's just simply too much work to do in one build, but I'm going to try to get all the resistors in tonight and then kind of go from there. So showing this module, its main purpose is not to like be a Eurorack module, but to help you build Eurorack modules. So like there's been a lot of times where I need to calibrate an oscillator and it's kind of really out of whack, or there's been some times where something doesn't quite work right in a module and then I'm trying to bring it over to my bench and get all the voltages that I need. And Eurorack has 3 different voltage rails, 2 of which are pretty common to use, the negative 15 or negative 12 and 12 volts rather. And so this makes that a lot simpler at my bench. I don't need to bring my whole keyboard over. This can make gate and CV, it can do test patterns, it can generate known stable frequencies that you can tune against. It can also test the power rails, and it's made by a super awesome guy. I linked his website in the description. But you buy the board from him, and then you have to buy all the parts yourself. And he gives a Mauser build list that's pretty good and pretty comprehensive, but some of the parts are old. So I went through and ordered it all myself. If you want to build one and you have any questions, feel free to reach out to me over Twitter at NBLenore, and I can try to show you which parts I bought. I ended up having to buy some from DigiKey, some from Mauser. But anyways, let's go ahead and get this started. We're going to be doing the resistors first, so I'm going to get my clippers. And sorry if I'm a little more discombobulated here than I normally am. I just got all of my streaming set up back at my bench, so I'm still kind of working through the motions here, but I wanted to get at least something streamed tonight. So we got a bunch of resistors here. It's kind of hard to get a pointer. It's kind of hard to read probably from the camera, but these are all 220 ohm. This is going to be 100K. There's a bunch of them spread out here. I got the pile of resistors here. The first part of the build, the simplest part of the build, is just going to be to put all the resistors through, bend the leads, and then go through and just solder them all one after the next. So, cool. Let's take a look real quick at the chat before I get the soldering iron in my hand. Yeah, not quite a Eurorack module build. It's a Eurorack module builder build. It's a thing you use to make and debug Eurorack modules. Alrighty, so let's see. I'm going to need my flex pen. Got my soldering iron already heated up. Don't have to do any desoldering this time. The one that we have the most of is these 220 ohms. So let's get into these first. Let's see. These are my 10K. These are 47K, 33K, 220 ohm. And whenever you're getting a like when people do build sheets from Mauser and they link all the parts, they're usually linking exactly what you need to build one copy of that, like whatever module or whatever the build list is for. But like when you're buying resistors, like buying 2 resistors, oh here I'm gonna hold up the camera, buying 2 resistors and buying like 20 resistors is not very different in price because of the volume quantity discounts and because of shipping. So like I recommend that you don't just get the build list and then hit buy. To actually like go through the build list and try to figure out like, are you going to use a lot of this component? Like for instance, for the DC power modules, which I have down here. Where's it at? Yeah. Okay, like for instance, for these DC to DC power modules, this thing, Traco Power, I'm going to hold it up this way too. Whoop, there it is. There it is. This is like a pre-made DC module. There's integrated circuits and components within this. This was like 20 bucks, so I'm not going to buy 5 of these, right? So I get one of those, but on all these resistors, I'm pretty stocked now. And the parts, or the components that he selected are all pretty good, decent tolerance. Yeah, these are all metal film resistors instead of carbon resistors. So now I'm well stocked, which works out pretty well. So we're going to do the 220s. Right here we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8 of them. So I'm just going to count out 8 here. 1, 2, 3, 4, 1, 2, 3, 4. Goes down. And now I kind of have my build set here. So let's go ahead and take these. I usually use a set of smaller needle nose to do the lead forming. I don't like doing it with my hands because I don't feel like it's precise or consistent enough. But let's see. Oh, see, this is expecting a smaller component than the one that I have. So what we're going to do instead is we're going to do these like verticals. So we're going to keep the lead formed. I should put my hands in the frame here. We're going to keep the lead formed as like straight down as we possibly can on that side, and then we're going to curl this other one around like that. And now, keeping these consistent, we'll put the long end on this side and the short end on this side. You can get resistors that have preformed leads that are exactly this, actually. Matter of fact, I have some in this pile here. They're prettier than what I just did, but this will do. Now, one thing that I'll need to, you know what, I'm actually going to do these back to back, or reversed, because ideally, if you're doing something, I really wish that these resistors would just fit. This was not intentional. Ideally, when you do this, you are going to have leads that have some sort of conformal coating on them so that they don't hit each other. Am I going to need to heat shrink tube every single one of these leads? Oh, it's not looking good. Maybe I do. Wow. See, now I just went on a long rant about how I ended up customizing the build order from the person who made this, and now I am realizing that the reason that those components were out of stock, specifically the reason that some of the resistors were out of stock, was because he bought smaller than usual resistors. How close can I get this if I do it like this? Okay, no, we're going to do it like that. I can do it if I bend them very precisely right at their base. Making sure that I'm not damaging these things in the process. Not my best work, but it'll do. Okay, yeah, that'll be better. Okay, next. Got to get it bent right up against the component there, or it is not going to fit. And with resistors, you don't really have to worry about polarity. I mean, if I wanted to be really pedantic, I could go through and make sure that every resistor was oriented in the same direction, but this is not a thing that I'm giving to someone that I'm working on it for, or something that's going to do anything other than sit on my bench and get abused with mostly broken Eurorack modules or half-built Eurorack modules. So it's going to look like more of a prototype. All right, almost. Just going to take the lead and I'm going to pull on it a little bit because I didn't quite get it formed so that it went in perfectly smooth. That's good. All right. Last one. Yep, now see, if I smash this down, I'm going to deform the lead out this way, and then it's not going to go in. So instead, I'm going to take my pliers from the back of the board, grab the leg, and just kind of pull it down into place. Okay, cool. And now I'm going to take all these, I'm going to push them to the side. Try not to mangle them too much, but yeah, I just want them to hold there. Okay, there we go. Cool. Now I can put my flux pen on. I'm going to just check the chat real quick. Oh, yeah. Yeah, I mean, I'm probably always going to look at this board, and every time I look at it, I'm going to think about the fact that I didn't put all those resistors in the right direction. If I wasn't doing this on a stream, I would probably pull them out and then meticulously go through. But maybe it's a good exercise in me not being a compulsive weirdo and just, I don't know, it's cool, it's fine. They don't got to go in a certain direction. I will evolve beyond the need for all the resistors to be exactly right. Should I try using my unleaded solder this time? I should really use a fresh tip if I'm going to do that. Maybe I can. Yeah, it's pretty clean. Let's try using this way, because, okay, I have this Heiko right here. You can't really see it. I had the camera less zoomed out, or less zoomed before, but then you couldn't really see the board work. I have this little device right here, this thing. It is a filter with a fan in it so that it sucks the smoke away from my face. I like to use it when I'm working by myself because I don't want to inhale lead and become even crazier than I already am. But it's really loud and it makes streaming this pretty much impossible. So since I'm not working on old electronics this time, like the pedals, I'm going to try just going for the green label. This is the lead-free solder. What mix is this? This is 97 SC. I am not as familiar with the compounds for the unleaded solder, but I tried to find one that would be roughly equivalent when I did the research to buy it, and so far it's worked okay, but it just never works as good as actual solder, if I'm honest. Okay, let's see if I can get an angle where you can see a little bit better what's going on. Let's see. Let's see if I turn this like this. Let me see. Yeah, that should be good. Cool. Alrighty. So my rule of thumb is to try to have this on for no longer than 2 seconds, even though these are resistors and they're not particularly temperature sensitive components. Just good practice. And I mentioned this before, but it's worth bringing up again. I tend to use the solder, the liquid solder, on the tip of the iron, not to tin the part necessarily, but to make a thermal bridge between the workpiece and my soldering tip. Like, if it's just a little piece of metal hitting another piece of metal, it's much harder to get it to to quickly get the heat where it needs to go. But if it has a little bit of solder on it, then it tends to work pretty effectively to get what you're soldering onto actually warm, so that you don't get a cold joint and you get a good alloy. Let's do this. I'm going to add a little more flux. I'm not seeing, there we go, not seeing this behave the way that I like it to behave. So a lot of little, just kind of push down kind of hard those, or kind of recessed. A lot of little things about the shininess of a solder joint and the concavity of a solder joint that help to tell you if you screwed it up or not. Thankfully, you can screw it up pretty bad and it still works, and I screw up a lot and it works, but it's always nice to try to get better at it. Cut off all the leads. Okay, that bank of resistors is done. Let's go ahead and let's see if we have any other 200s. And I need to be careful to put these, or 220s rather, I need to be careful to put these back in their bag so that they're labeled, even though I could read them. It's annoying. Okay, I see one. Yep, it's just one. Right there. So, got one more. And if you're in the chat, sorry if I'm not talking back to you at the moment. What I'm going to do is I'm going to kind of go back and forth between like making a pass on this and then talking in chat and socializing a bit. Okay. There we go. That went in. Let's see. Yeah, welcome to the Compulsive Video Club. Yeah, I'm gonna. Yeah, I'll paint. I'll put the whole. I'll pot the whole thing to make it impossible to work on. But then no one can tell that I slightly fucked up in a way that doesn't matter. It would make. It would make me feel a little better. I'm gonna learn. This will be an exercise in my psychological and personal growth, in trying to just be okay with the fact that I didn't do it just right. What kind of resistors do we got a lot of next? We got a lot of. I see 1, 2, 3, 4 100Ks, 5 100Ks. Yep, 5 100Ks, so put these back. Glitter potting compound. Is there obnoxious potting compound? That would be awesome, actually. I mean, what if you potted the areas that, like, didn't have the parts just so it looked cool? Yeah, I should really pay attention to the soldering iron. I have burned the shit out of myself so many times with a soldering iron. I think I burned myself with a soldering iron just a couple months ago, actually. I burned myself in the pinky, and it was my fretting pinky. And then I just played Guitar Wars for like a week or two until it healed because I wasn't paying attention to what I was doing. 100K. By the way, speaking of like obnoxious colors of electronic components, I love this rainbow ribbon cable. I think this shit's awesome. They should make this in more colors. I would love to buy like trans pride ribbon cable. That would be fucking awesome. I don't care if every wire is the same color, like in clusters of 6 or whatever. Let's see. Okay, so we're doing the 100Ks, and I got 3 of them down here first. So we'll go 1, 2, 3. So this speaking a little bit more about this particular unit and why I ended up looking for and finding this is because I've been attempting to calibrate my Eurorack oscillators recently. I've been specifically trying to calibrate my my Dixie 2 Plus by Intelligel, and I've been trying to calibrate my NW1, which is the Intelligel Dixie 2 is a single oscillator VCO, so just a regular old analog voltage controlled oscillator. It does have LFO and like tone level range, and it has a bunch of different wave shapes. It's supposed to be very stable and have good key tracking, but I have had an absolute nightmare of a time actually. I probably put 10 hours into calibration, and it doesn't track correctly. And one of the things if you're not like super into Eurorack, or just into like analog synthesis in general, one of the hardest parts is tuning and calibration, because the way that it works with the way that you tell modules what the note is, right? Like, because it's all just like a voltage. It's a voltage between 0 and 5 volts, 0 and 7 volts, 0 and 10 volts, depending on what's happening. And so, it doesn't have MIDI. It's not saying like I'm putting the C note. This is the data for the C note, because it's just one electrical connection. So the common standard is called 1 volt per octave. So that would mean that if 0 volts is C0, then 1 volt would be C1, 2 volts would be C2, 3 volts would be C3, all the way up the scale. And so that means that you can have a single cable that is just a two wire cable, a coaxial, or just like a regular. It looks like a mono audio cable essentially, that you can send all of the notes over that one cable in analog just by the 1 volts per octave division scale. But the tricky thing here is that, like, okay, let's say that your keyboard, like, does exactly that. So on my KB37 Eurorack keyboard, I have a pitch plug, and when I plug something into the pitch plug, it makes exactly 1 volt per octave all the way up to scale. However, when that gets into the module, like, there's a bunch of calibrations that have to actually happen, because the module needs to offset whatever because, like, for instance, the keyboard does not make exactly 0 volts. It makes 0.02 volts. That's slightly out of pitch. So first there's an offset to get that, a trimmer, a little tiny knob. I have some in the box, but a trimmer is like a little adjustable potentiometer. So you have to trim that to 0 volts, but then there's also what's called the key tracking. And that means that, like, in the analog circuitry of the module, it needs to make sure that as it goes to 1 volt, 2 volts, 3 volts, 4 volts, that reflects a frequency shift in the oscillator of whatever that division is. So, if you're at 128 hertz and then you go up at 1 perfect octave, you're now at 256 hertz. There is obviously, like, I'm using like powers of 2 because they're easy to do the math on. But essentially, you have to make sure that the oscillator is calibrated so that it tracks with that keyboard correctly all the way across the scale to make all the frequencies correct for all the keys. And on that Intelligel module, there are 4 trimmers. There is a low frequency there's a VCO offset, low frequency offset. There is a VCO bias, aka low frequency bias, and then there is a high frequency offset and high frequency bias. And essentially, when you're doing that, you are setting 4 points on a curve, like the offset point, and then these bias points that kind of bend if you had a graph of, let's say voltage is on the x-axis and frequency is on the y-axis. Is that right? Hold on. Frequency, if you have a graph that you're essentially trying to keep the line flat so that you get one-to-one key tracking, essentially, so that, when you go up to 1 volt that you get C1, and when you go up to 2 volts you get exactly C2, C2 being in frequency output from the oscillator. You have to go in and tune that to get that to like land just right. So you have to go tune them all in a certain order and then do it again and then do it again and then do it again over and over and over and over again. I have done that for 10 hours now, and because it takes so long to switch between the different voltage ranges that I have to test with to calibrate the whole scale, I really wanted a better solution. I wanted a solution where I could literally have it dial in a pattern and then adjust them without having to get away from my bench, with having my actual oscilloscope versus just a multimeter. So, wow, what a segue. Long story short, this module here is going to sit on my bench. I'm going to make a little clear plastic undercase for it. And its job is going to be to help me calibrate modules and to work on them, especially because I have a project coming up next, which is this thing. This is a Bafaco envelope generator. It's a kind of well-known one. Here's the front plate, if you recognize the front plate at all. It's a really, really good envelope generator. I'm really looking forward to having it on my Eurorack. However, it's quite a complicated build, and I would very much like to have this working before I take on that project, because if something goes wrong and I'm not able to test it at my bench, I am not going to be able to fix it. Okay, so we have these 3 resistors in. What are the one? We have another 100K here, and we have I could have swore there was one more. So there's a 100K there. There was all of those. 10K. Those are capacitors. 100K. No, 150K. 100K. Okay, so it's just that 100K. Okay. So get this one in. Get these back in their bag so that I do not get them mixed up. And through. I wasn't super precise with bending the leads, so once again I need to flip this over and just pull like that. The rest of those are good. Okay. Keep reaching up for my laptop keyboard, but I put one down here now. Okay, trying to be able to see what I'm doing. Okay, so let's do these ones first. This right here is my, you can kind of see, it's a flex pen. Most solder has what's called a rosin core or flex core. So there's a little bit of flex in the solder. I like to be able to pick from a wider variety of solder and also just have some in the pen. And I've mentioned this before, but it's really important to have flux, because if the metals that you're trying to weld together with soldering are oxidized, like soldering isn't just a matter of like using some metal to stick 2 pieces of metal together, right? Like soldering is like a chemical process that creates an alloy, a new metal, as a combination of the solder and the metal that you're welding to. And if there's oxidization on the surface at like a molecular level, it can't, the chemical reaction can't happen. And so it doesn't actually solder, and that's how you get a dry joint, because you didn't make an alloy. So that what the flux does is when the flux is, way too much solder on that joint. When the flux is there, it helps the solder penetrate any oxidization. It actually helps to break off the oxidization. And so the alloy formation happens much more consistently than it does if you do not have the flux. And on older electronics, they have certainly oxidized quite a lot, even older components, like older resistors that might be in your parts bin. So you should really expect to need to get in there with the flux pen. Now, certain fluxes are nastier than others, and so you have to clean them off. I have a flux cleaning pen as well. But this particular flux, it's not too gross. It doesn't stay too sticky afterwards, and I'm way too lazy to scrub the flux off of everything unless I really need it. You can see a little bit of flux there. If I'm doing work for somebody else, I'll clean the flux off, but for my own stuff, I can't really be bothered. Okay, so let's see, what do we got next? We're moving through the resistors pretty fast, actually. This board isn't as hard of a build as I thought it was going to be at first. We got a 10K, we got a 10K, we got a 10K. So let's go for those. So we got, these are the 100Ks, those are done. Now the 10Ks I can actually show you. So I said I had 3 10Ks, right? The 10Ks are preformed like I was bending those other ones too. And this wasn't because I specifically wanted these, this was because this is what they had in the quantity and pricing that I wanted for the tolerances that I wanted. One of the things that's kind of overwhelming when it comes to like building electronics is like if you go to look for like let's say you have to buy a 0.1 microfarad capacitor, and you go on DigiKey and you look for a 0.1 microfarad capacitor, you're going to see a million parts. And if you're like an electronics guru, and I'm kind of envy-splaining electronics, I apologize. It's not for you so much. I'm trying to also like, you know, make it to where you don't have to be like a super electronics nerd to learn something and know what's kind of going on. But anyways, there's a lot of different options when you buy components. Between the tolerance of the components, like you can get capacitors in multiple different materials. There's ceramic capacitors, there's multi-layer ceramic capacitors, there's electrolytic capacitors. They all have their own like ideal use and function. Sometimes it's for cost, sometimes it's for just whatever the application that you're doing is. But there's also a lot of different variants for, like for instance, is it taped together on this wheel that has punches out of it? Is it taped together like these other resistors were? Is it in a bin? And that has to do with the process technology for the factories that make the that assemble electronic components, right? Because sometimes they're using a pick and place machine. Sometimes they have a feed system that needs a certain tape and reel versus it being in a track or something like that. So it can be a little overwhelming when you're trying to order parts because there's just so much to choose from. So what I usually try to do is take the things that I know the best first, filter it as much as possible, and then sort from cheapest to most expensive, and look for the ones, and filter out any of the ones that you can only buy in bulk. And from there you can kind of narrow it in, but part of it too, if you're doing that and feeling overwhelmed, like just keep at it, because eventually you kind of figure out what the noise is, like what the stuff you don't really need to care about is. And like if you're trying to buy like electrolytic power supply filtering capacitors or like decoupling capacitors, I mean, I'm not going to say that like the electrical series resistance, the ESR, is not important. I mean, like it always, it's, you know, it's a thing. You should be aware of it. But like honestly, if you buy one of the normal ones and not one of the ones that's like super special, it's probably fine. Like those specs are there so that when you're doing something specific that you can get the right part. But for most purposes, it's really not going to be the end of the world. If you find yourself stressing out about it, just buy one. And if it doesn't work, you're going to learn something. And it's not, you know, it's resistors and capacitors. It's tens of bucks. It's not going to hopefully break the bank. Okay. Come on. Touching that so the board doesn't turn. Okay. One other recommendation, if you're going to be doing this stuff more than just totally randomly and casually, investing in tools, if you can, is a good idea. Getting a good pair of diagonal cutters, getting a good pair of pliers, getting a decent soldering iron. There are really good soldering irons that are not super expensive now. You want to look for the direct tips. They like plug into the tip of the soldering iron instead of being screwed in like these typically. Um, they're really accurate and they work very well, and they're not super expensive. Try to avoid like go watch some YouTube videos, right? Like don't just buy something because you saw it on Amazon. Like because if you have crappy tools, it's gonna make it a lot harder to do decent work, and um, it only takes a little bit of shopping to spend the same amount of money for something that's gonna serve you better. Okay, so that's 10Ks in the box. Let's see. We got 33 is there. I'm seeing a couple of 470s. Yeah, let's do 470 next. There's 470s. 1, 2, 3, 4. Okay. That's the 47, 33, 62, 470. And go say hi in the chat. Actually, and I'm also gonna have y'all are too nice. Yeah, I'm glad that some of this info is like useful. Like I'm not trying to just drone on. I'm just trying to share some like I don't know, the basic stuff that to me is helpful to like be able to get shit done because I've had to teach myself most of the stuff that I've learned to do, especially the nerdier stuff over the years, and it can be really overwhelming. I mean, I spent a long time not knowing the basics and then doing it badly and not knowing how to get better, and then when I spent some time to just like figure out some of the basic things. There's a really good series of videos from the 1960s actually by Pace, who makes soldering systems, about how to solder well, like by like I don't know 1960s defense industry standards. So it's like they're really pedantic about it, but it's also they're using pretty simple tools, and I'll share them again on Twitter at some point soon. Or if you're interested, reach out to me. Actually, you know what? I can just drop these in the chat right now. I can do, it's Pace soldering videos on YouTube, and it has that awesome like vintage. I don't know, vintage like it's like your teacher's rolling into the classroom with the TV cart and the VCR, and it looks kind of like shit. And the lights don't all turn off because you know safety or whatever. But it has that vibe, which I think is pretty fun. Let's see. Okay, yeah, I'll post it right here in the chat. Okay. There we go. Just posted in the chat. There's a whole series of them, but they're really good. And actually, I relearned how to solder from these videos after doing it for many years and just sucking at it a lot. Oh, I'm just checking in on the Periscope chat real quick. Sorry to be focusing on just the Discord folks. Thanks everyone who's like tuning in and stuff. There we go. I'm logged in now. And this is the link to the video that I was talking about now over on the Periscope chat too. Cool. All right, so back to the build. Oh, actually, one really important thing I forgot before I continue the build is to have some of my beer that I've had here the whole time and not been drinking. All right, word. So 470 ohm, and we got 4 of them. So where's my clippers? And whenever I'm building a module or like assembling any PCB from scratch, this is usually the part that's like kind of the most brain dead. I would say the most boring. Definitely the part that like has the least amount of like, I don't know, like it's not like I'm soldering stuff and then little lights are flashing, right? Like this is the part where you're doing a lot of the the basic foundational stuff you just have to pay attention and get right, and then once we get into the part of the build where I'm soldering on knobs and the display and I can start to power the thing up, it's going to be totally worth this super boring, just look at the board and put the part through the whole section. And that's for me too, not just for anyone who's watching right now. Something I've had to kind of learn over the years is how to like approach projects so that I can stay, I don't know, entertained enough or engaged enough to not get, I don't know, 3/4 of the way into it and then get bored and then let it sit forever 3/4 of the way finished, which I have plenty. I have closets that will tumble themselves outwards onto me, both physically and metaphorically, of unfinished projects that I've done exactly that with, gotten most done and then most of the way done and then just like, I don't know, got burned out and stopped giving a shit. Especially because I do like software for a living, so it's like, fuck, finishing projects is hard and I have to do that shit for work. Sometimes I want to just do something nice and chill, but I also want to be able to enjoy the things that I build, and to do that, you got to finish them, it turns out. Okay, that's good. In here. Bend these legs. And I hope you can see the board okay. My camera's a lot more zoomed than it used to be. Well, zoomed, I mean, I moved the camera closer because it's a fixed lens, but I tried to get it to where there was a good balance of like focus and making it like close in enough and being able to move the board. So if you're having a hard time seeing what's happening, let me know in the chat and I will go over to the camera and try to focus it and reframe a little bit. It's pretty tricky doing these like tech streams by yourself. I know a lot of people do. The best setup is to have a camera like directly above your head, but I don't. This desk is up against the wall and it's very heavy. I'm not going to move it, so I have to put the camera off to the side, which is where you're seeing the build video from. I also hope that the audio works better this time. So the last stream I did, the audio was pretty quiet, and I couldn't really make it louder because I was compensating for the fact that the laptop I use to stream in here is really, really loud. And also I replaced all the fans in my server down there to make it quieter too. But I did some noise canceling this time, so I did some testing and the hopeful, yeah, cool, I'm glad to hear, yay! Pippers and circuits. Yeah, it is pippers and circuits. I'm glad that the audio is good this time and that the camera's good. Thanks. I'm way more like experienced doing like actually composed videos where I record a bunch of footage and then edit them and go massage everything. So the streaming thing, see, I didn't get this resistor down all the way. Well, it lives slightly off the board now. Doing the streaming is a little bit newer, so I'm still working out some of the warts as I go along. Do we have any other 470 ohm? I thought we already did those. Yeah, we're good. We need 47K. Get out of here. 47K. And how many 47Ks do we have? I think we have quite a few. 1, 2, 1, 2. I could have swore I saw a third one. Nope, just those 2. Alright. Well, you can see that I bought more than 2. Because I think that this entire, like, buying 2 was like gonna be like a couple bucks or something, and buying all 20 of these was, or no, sorry, 50 of these was like less than $5. Yeah, the streaming stuff like is really a rabbit hole. Replying to one of the comments in the Twitch chat, um, like I don't know, with any kind of like media art, it's like you can just always keep making it better, and like not only just learning and making it better, but also like I don't know, like buying equipment to make it better. At some point, you have to like stop spending money and just take time to learn everything. But but it's definitely something that, especially in the post-COVID world where I don't get to see people in person very often, and so I'm spending a lot of time on voice and video chat. Yeah, I want it to be fun and cool. I want it to look good. I want to be able to, I don't know, not just be a fuzzy character on the other end of a camera, but like have it look good. My main streaming setup in my studio is pretty good. I have a ring light set up and everything, but of course the lab is a lot more cramped, and I don't have as much room, so it's a little trickier of a setup camera-wise in here. Took me about an hour today to get it all set back up again. I had the equipment moved to a different room. One of the other funny things is you have to like become aware of like, am I soldering in front of the camera? Can people like I would normally put my hand here to do this, but like if I want you to be able to see, I have to like just be aware of the camera angle. Alrighty. Cool. I think 33K is up next. Yeah, we got 2 of those. We're gonna be done with the resistors here in just a moment. Let's see, go and check over on the... Alrighty, so 33K is next, and we need 2 of these ones. Two. I really wish that you could, I don't know, that I could like play music or something, because I'm usually doing this stuff with music on, and obviously if you're watching me, it's like, maybe I don't want to talk the whole time. Maybe we can just hang out and listen to tunes, and then I can be building my thing. But Twitch will ban you pretty hard for playing licensed music, and YouTube will automatically remove your content. I think Twitch will in some circumstances. So it doesn't really work. It's like they should just have a deal with Spotify or something, and like if you're buying a Twitch subscription, you should get to hear music. I don't know. It seems like a thing right now that's like impossible, but in 10 years when we have the whatever is going to be after the Zoomers, like I have a feeling that eventually, like, people are just going to have music on while they're streaming. It's going to be a totally normal thing. I'm looking forward to them. Whatever event will make them actually, like, sort that stuff out. Right here. Okay. It down to make sure. Last time I didn't get one pushed down against the board all the way. One thing to watch out for, by the way, if you are using lead solder, and if you're doing work on old electronics that are not lead free, you have to use leaded solder because you can't mix them. Is like, I don't know, I'm weird. I touch my face a lot. I itch my nose a lot. I'm always fidgeting with my hands. If you got lead on your hand, you do not want to touch your face. That is the fastest way to get lead in your face. And it's bad for you. It's not even fun, and it's bad for you. It's stupid. Don't do it. No lead. By the way, these little things, all these little cutoff wires, I save a lot of these. They make really good jumpers, and sometimes I just need a little piece of wire, and these work out pretty good for that. Let's see, we only have a few resistors left. So we got 150K, we got 1 meg, we got 10K, we got 82K. Oh, I did miss the 10K. There's a 10K right there. Let's do that one first. I think I'm gonna get the resistors done, and then we'll see. Let's see how I'm feeling. I might get the resistors done and then call it a night, and then do part 2 through the end of the build. But maybe I'll also do the resistors and then I'll solder. Maybe I'll solder the sockets on. I'm gonna think about it. Okay. That 10K that goes on there. And I'm not going to solder this to 10K by itself. So let's just like do a little bit of a speed run here. So now we got 62. We only have one 62K resistor we need to put on here. Yeah. So we will do this. No other 62s. Last call. Out of here. I should probably make a point to do that in front of the other camera. You know, I have so many, I have a lot of habits about how I don't know, use my hands that are not built around doing it for your viewing pleasure, but are around what is comfortable for me. Okay, 150 is next. We got 1, 2, yeah, just 2. So, take this. No other 150s. None. Although I can see 100K that I believe that I missed. Did I do 100Ks yet? I did. I'm gonna have to go back for that one. Shout out to everybody in the Chaz right now. I doubt any of you are on the stream because whatever you're doing is a million times cooler than this shit, and tried to take the East Precinct back. I used to live just down the street from there in Capitol Hill in Seattle. I have a lot of friends who are there right now. Yeah, last I heard the cops fucked back off, but yeah, solidarity if you're out there, because I don't want any of y'all getting hurt, and I think that the Chaz is one of the most inspiring things that's happened in American society. Well, I mean, including the protests, I guess, which is not just that, but obviously all the Black Lives Matter activism that's been successful and awesome the last couple weeks. But yeah, having an autonomous zone in the U.S. is like no one would believe you if you could say that you would kick the cops out of your neighborhood. They'd think the cops would just kick your ass. They'd probably be right, but so far, they've held it down. Viva la Chaz. Where's that? That was 100K that I missed. 470, 3K. Okay, 100K. Just need one. I think that we're going to be able to get all the remaining resistors in this pass. Cut, cut. This box back down. And the 82K ohm. 1 meg ohm is in. Oh, sorry, the 100 ohm is in. We gotta put the 1 meg in right there. Do we have any other 1 megs? Going once. No, we're good. Okay. There we go. Nice, that one went in nice and easy. Using the pliers does help. And then I think it's just this 82 kilo ohm. I'm looking around the board. I don't see any others. Sweet. This is the last resistor. Well, last fixed resistor. We do have trimmers, potentiometers. Ooh, and we have a label on the board for a 0 ohm resistor. They do exist. They do make resistors that are 0 ohms. They're not really resistors. They're actually shorts. They're just a piece of wire, but they will manufacture them into a resistor, so it'll still look just like a resistor, and it'll have the color bars to tell you that it's 0